Chapter 8 Probability. Now we'll start with permutation and combination, and here are the formula that we always use in this topic. The first one, n factorial. The exclamation mark in this topic we call factorial. So when we use n factorial, we're going to arrange something. There is no condition. We just want to find out how many possible ways the different things can be arranged. Second, NPR. When we use this formula, we are going to choose and arrange something. Let's say, for example, I have 10 candidates, and I'm going to choose 3 of them, and I have to arrange 3 of them because let's say there is 3 tasks, A, B, C, 3 tasks, and the 3 candidates that I choose just now, I have to find out how many possible ways that I can arrange them in this different 3 tasks. Okay, the third one, NCR. When we use this formula, we are just going to choose something. Just like the example just now, 10 candidates. I just want to choose 3 of them to work. Okay, therefore, n factorial over r1 factorial. R1 is the similar object. For this, I will explain it later with example. And one of the important thing I also want to remind is that this formula, NPR is equal to NCR times R factorial. Example, in how many ways can 5 boys and 2 girls be arranged in a row? A. No restriction. B. The 2 girls must not be side by side. Okay, so we start with A first. Let's say there are 7 seats because we have 7 people. 4, 6, 7. Okay, 7 seats. And how I'm going to arrange, because there's no restriction, that means I can arrange it anyway. So B1, I start with boy 1, then boy 2, boy 3, boy 4, boy 5, girl 1, girl 2. But I also can start with boy 2 first, and then boy 3, boy 4, boy 5, boy 1, girl 2. So there's too many possible ways. If you want to calculate one by one, maybe you calculate until next year. Maybe you did some error when you're calculating. So there's a formula called n factorial that I showed just now. So you're just going to put the number, how many people there, 7, then factorial. Key into the calculator, you can get the answer directly. So B, the 2 girls must not be side by side. Okay, how we are going to do this? Because the 2 girls are not going to be side by side. There are 7 seats. Let's say, okay, yeah, five boy. That means the boy, because the woman cannot be side by side, right? So they must be in between the boy. So boy, boy, boy. And then how many possible ways the girl can sit? First one, second, third, fourth, fifth, sixth. There are 6 possible ways the girl can sit in between, like the first one sit here, the second sit here, or the first one sit in the front and the second sit in here. Okay, there are too much possible ways. So first, the answer is 5 factorial, because this 5 boys, they can arrange themselves. It won't affect the result, but you have to times with 6p2, because there are 6 possible seats that the girl can sit, and you are just going to choose 2 and you're going to arrange them. So after you key into a calculator, you can get the answer. Now next example, the letter in the word banana are to be arranged. So for this, we'll use the fourth formula that I said just now, n factorial over r factorial, r1 factorial. The r1 is the similar things. Okay, from this letter, you can see that there are some similar word like 3a and 2n. So we start with the formula n factorial divide r1 factorial. Okay, the n obviously is the number of word, 6 factorial, divide by how many similar things. There's A, 3A, that means you're going to put 3 factorial because 3A is the similar thing. But there is also 2n. Because n are similar, so 2n times with 2n. And then you'll get answer 60. So next example to show another formula. In how many ways can can a committee of 2 male adults, 4 female adults, and 3 boys be chosen from 6 male adults, 8 females adults, and 4 boys? So that means you are going to choose two male adult, 4 female adult, and 3 boys. Okay, so 6CR because you're going to choose 2, 8C4 because you are going to choose 4 of the female adult, and 4C3 because you are going to choose 3 boys. For this, you are just going to choose, you are not going to arrange them. Permutation and combination. Now we look at the partial question STPM 2011. This is a probability question. The number of shirts by color and size in a batch of 100 is shown in the table below. 2 shirts are selected at random without replacement. Calculate the probability that both shirts are of the same color. B. At least one shirt is large. So let's look at the solution. First thing, we write a capital P. This shows probability, and then open bracket, and we list down what we want to find and close bracket. The things we want to find is same color. So there's only 2 possible ways, either 2 blue or 2 white. So I have to calculate the total number of blue color shirts, 40, and then white color 60. Okay, so total 100. So probability of same color. We start with blue first. The first we have to pick one blue. So 40 over 100 because there's 40 blue shirts and the total number of shirts is 100 times with 39 over 99. Why? It is because after I take one blue shirt, that only left 39 blue shirts, and the total number of shirts only left 99. Yeah, so that's the reason why 39 over 99. If with replacement, it will be the same, 40 over 100, because this is not without replacement. So the same goes to white. The initial 60 over 100 because 60 shirt is there. After I choose one, left 59. So 59 over 99. So you can get the probability of the same color shirts if you want to choose same color shirts. Sorry. So B, at least one shirt is large. So at least one shirt is large. That means it can be one shirt as large or 2 shirt as large. So the first, let's say I choose first large, I get first large and second is not large. But it is actually different when come to the first is not large and the second is large. Maybe most of us think that there's no difference because it's the same thing. You are just going to choose one large, but the arrangement is actually matter. So you have to, so the first one is not large and the first one is large is different, it's totally different. So this is shown by the solution here. The first 23 over 100, it is because we have 23 large shirts, 23 large shirts, okay, time with 77 because the not large is 77, the total number of not large, over 99. Over 99 is because I already choose one large shirt. So see, the same goes to the second one. First is not large and second is large, and then there's also possible of 2 large. So after I calculate this, after I get the possibility and then I plus it, you get a total possibility of getting at least one large shirt. Venn diagram. The picture on the left hand side is the Venn diagram, and it is very easy to draw. You just have to draw a big square, and then you just draw 2 circles intersect each other, and you list down the event A, event B. So that's all. So it's a very easy to draw and very useful, very helpful when you are going to answer the question. And the formula is also very important. You have to memorize all of this formula. So now we start with the first one, A union B. Another term for union is OR. OR, or, okay, another term that we use for union, equal to PA plus PB minus PA intercept B. Intercept, or we can say PA and PB. So now I'll sketch for you. I show you what is PA. The PA is event A. So event A is this area. This area is called event A. And then event B is another area. This area called event B. Okay. So PA union B, A or B. That's mean the whole picture. A and A or B. A or B. So these all are A or B that I sketch. So A and B. A and B, that means the middle part only, because this intercept A and B. If let's say are not A and not B, not A and not B will be outside the outside area. Yeah, this is not A and not B. Okay. So now see the formula. PA union B equal to PA plus PB minus PA union intercept B. The second formula, PA union apostrophe B, something like apostrophe B, this is called not B, equal to PA minus PA intercept B. PB union apostrophe A or not A, you equal to PB minus PA intercept B. And P not A equal to 1 minus PA. So I will show you later in the example. A and B are two events such that PA equal to 0.5, PB equal to 0.6, and PA union B equal to 0.85. So you have to find all this, find all the answer. Okay, solution. The first one, PA, because we want to find PA intercept B, but we don't have the data here. So the things we can do is we use the formula that I showed just now. PA union B equal to PA plus PB minus PA intercept B. So because we have the value of PA union B 0.85, we just fill in equal to PA 0.5 plus PB is 0.6 minus PA union B. PA intercept B. So after we rearrange, we'll get the answer. PA intercept B is 0.25. So we want to find the second one. So if we want to find the second one, it is very confused because we don't know which part of it. So it is better for us to draw this diagram when we want to do this question. So initial things we have to do is draw this diagram, and we list out. Okay, so PA union B is 0.5. PA equal to 0.5, PB equal to 0.6, and now we already get the value of the PA intercept B. So 0.25. The value here is 0.25. So if the value here is 0.25, you can just use 0.6 minus 0.25, and you get this part. You get the value of this part, 0.35, and then the other part will be also 0.25. And the probability when we add up, it will become 1. It cannot exceed 1. Okay, so after we add up all the event, it will become 1. But here we can see we only get 0.85. Okay, from the event A and B we only get 0.85. So outside here, the outside event out of the event A and event B is 0.15, because the total probability is equal to 1. Okay, now if we already draw this, now let's look at the second one. PA intercept not B. What is mean by PA intercept not B? That means I want the part that PA intercept with the not B part. That means B is not included. That means we are going to use this part only. Okay, this part. So we have the answer direct, 0.25. But in the exam, we also have to show the step. Okay, so now let's see a third question. P not A intercept B. That means I don't want A, I just want B. So this part, you just want this part. Okay, so you already have the answer if you draw the diagram first. You don't have to calculate all this. You don't have to confuse yourself, okay? So after you draw this, you can directly get the answer, but you also have to show the step to get full mark. Okay, P not A intersect not B. That means out of A and B, so equal to 0.15. You already have the answer. So you can see that this diagram is very useful for you. If you draw this diagram, you can solve all the questions. Conditional probability. Probability of B may be different if the dependent event A has already occurred. So here are the formula of conditional probability. The things that happen you put behind, and you put behind, okay? And the things that you want to find you put in front. So let's say this formula, the formula is P bracket B intercept A divide by PA. The things that already happen you put below here. Let's say for this PB happened first and PB will be in the below. So the keyword, how you going to define when you want to use the conditional probability. The keyword is if and given that. When you see these two words, that means you are going to use conditional probability. So now let's see one example, STPM past year 2008. And here are the question. A student applies for 2 scholarships S and T to further study. The probability that he is offered scholarship S is 0.4. If he is offered scholarship S, the probability of him being offered scholarship T is 0.2. If he is not offered scholarship S, the probability of him being offered scholarship T is 0.7. Okay, now we have to draw a tree diagram. First thing we draw 2, because we draw S. That means he get a scholarship. First he did not get a scholarship. If he get a scholarship, the probability is 0.5. 0.4, sorry, 0.4. And we know that the total probability is equal to 1. So 1 minus 0.4, we can get a probability of his not getting scholarship S. So it's 0.6. So we draw 2 lines, okay? So he get T, he didn't get T. So the first, yeah, you can draw this like this. Okay, let's say if he get the scholarship S, the probability of he also getting scholarship T is 0.2. So he didn't get a 0.8 the probability, because 1 minus 0.2 will be 0.8. So they also say he is not offered scholarship as. Okay, he is not offered scholarship as, and the probability of him being offered scholarship T is 0.7. So this is 0.7, and the probability that he did not get is 0.3. So this shows the conditional probability, because this is, let's say, probability S. This is probability not S. And here will be the conditional probability. Probability that he get T. In the condition, he already get S. So this is the probability he didn't get T. In the condition, he get S. S already happened, yeah? So for this, P, he didn't get T. In the condition, he didn't get S. And the other one is P, in the condition, he get T. In the condition, he didn't get S. So this all this is conditional probability. Mutually exclusive and independent events. When events have no outcomes in common, they are mutually exclusive. When A and B are mutually exclusive, the intersection of A and B is empty. P A intersect B will equal to 0. The additional rule applied to mutually exclusive event is PA union B equal to PA plus PB. So when you want to prove something that is mutually exclusive, here are 2 things you can use. PA intersect B equal to 0, or PA union B equal to PA plus PB. These 2 things can show that if it is equal, this can show that they are mutually exclusive, because the question always asks you to prove it is mutually exclusive, and this is the formula you are going to use to prove. So independent. When one event has no effect on another, they are independent. So if A and B are independent, the probability of A happening is the same whether or not B has happened. The multiplication rule apply to independent event PA intersect B equal to PA times PB. So the other two things you can prove it is independent is use these two. If it is equal, that means the event is independent. So exhaustive event, the meaning is if event A and B are exhaustive, then A union B will equal to S, where S is a sample space. Complementary event, if event A and B are complementary, then event A and B are exhaustive and mutually exclusive. That's all for this chapter, and hope you can learn something from this video.